Okay, so let's start with a slight delay, as it sometimes happens in IT projects and all that stuff. I'm Michał. I'll talk a bit about event sourcing, and I'm really glad that Milan painted the landscape of the event X services and event related stuff before. So I don't know how many of you attended the Milan's talk before, but it was really nice. It build the background, build the foundations for what I'm gonna tell about. What I'm gonna talk about. So yeah, just some kind of obligatory information. If you want to ask questions to be answered after the presentation, just go to Slido. It's room 12. The hash code is GeeCON as usual. And yeah, and let's start. So what's gonna be the plan for today's talk? We'll talk about few stuff related to event sourcing, but in contrast to what Milan said, like on a broader landscape, I will talk about the stuff in a kind of local, in a local size, in a kind of context of a single service or multiple kind of neighborhood services. So first we'll see how the event sourcing looks like in terms of the state management. How does it differ? How does it differ from regular or the other approaches that we know? Then we'll talk about domain modeling a bit. How is it important and how it impacts the services, the way you build services. And also we'll talk about the consistency requirements and consistency, maybe guarantees or the trade-offs that you need to take. You need to be ready to take when building event source systems. Then there's going to be a bit about evolving systems, because event source systems are kind of special in their nature that you need to take care of the systems that you need to be prepared for the systems to evolve over time, over kind of a long period of time, sometimes years, depending on your project. Then, as usual, we'll talk about tools like frameworks, whether we should use them or not, to what extent we should use them, or maybe we should totally drop them. And then about event replay challenges, if there are any, and how to cope with them. Side effects, this is kind of tricky point in here. And at the end, building the read side, which to me is kind of the most appealing part of the event sourcing, usually. So let's start with how it all works. I hope, if you are being here because you already know, a thing or two about the event sourcing, or at least the general concept, how the thing works together. So basically, it all starts with the user when the user wants to do something with our system. So the user issues some kind of command, like, I don't know, sign the invoice, or kind of close the account, or whatever the command is gonna be, the command that needs to have an effect on the system itself. And that command lands in a command handler in our system, and then the state is not, the command is being issued against the state. But the difference in here in the event sourcing approach is that the state is not a single row in your database, or a kind of effect of joining two tables together or three tables together. It's just a transient thing, hence the cloud in here, is a transient thing that gets rebuilt on every command from the event stream. The events are the facts that happened previously for given aggregate, for given domain entity that you want to work on. For example, closing the account. So these are all the events that happened for that given account before. So before handling the command, you need to kind of reconstitute the state from the events from the event store. Hence, the events are going from the event store to the command handler. The command kind of your code kind of applies them one by one up to the moment where it has actual state, and only then the command gets executed against that state that you have just rebuilt. And then, as a result of the command handling, usually there's either one or more events being issued to the events journal, being persisted to the event journal as a result of the business operation on the aggregate. So, for example, I don't know, closing account or something may end up with emitting an event account closed, or multiple events. I don't know what the other can be, but in general, there can be one or more event being executed, being saved, emitted from the command handler as a result of business operation. And that's basically it in terms of command handling. There's another part of the event sourcing, which is the last one, basically. Last part of the event source system is this read side, which I said to me is kind of the most appealing one. I'll tell you about it more later. But this is the other stuff that kind of connects to the event store, event journal, and it kind of processes the events. It reads the events that were just saved by the command handler, outputted by the command handler, and sent to event store, saved in event store. It reads the event and it does something with the events, whether it's preparing a model for presentation to the user so that the user can see in his UI that, okay, the account was closed, whether it gets, I don't know, email notification, SMS notification, whether the other systems are getting notified about the stuff that user just closed the account. This is the part that kind of orchestrates all that and does all the read part for the event source systems. And this is basically it. This is all you need in order to build event source system and work with the event source system or understand the concept in general. So as you can see, there was nothing related to frameworks. There was nothing related to layers, controllers, I don't know, services, languages, approaches, or stuff like that. Because event sourcing, to me and to like many people I know or I follow, is just a different approach to state management. It's not like architecture, like full-blown architecture for systems, for entire products, systems, group of systems, entire services, like in a broader scope. It's just a different different approach to state management. Different from the one that we usually do, like the CRUD ones, so create, update, read, update, delete. Is it difficult? I mean, it can be difficult if you used to work like your entire life, or most of your life, with the CRUD-based systems. Switching to event sourcing may be difficult. It may give you some headaches at the moment because you need to understand and kind of get, like, internalize all the dance between events, commands, read models, and stuff like that. But on the other hand, we can flip the question and ask if the CRUD approach is difficult. I mean, if you were doing, let's suppose you were doing like event source system for your entire life, going to CRUD, would it be difficult for you? Probably it would be, because it would have different characteristics, different limitations, give you different benefits than event source systems. So to me, it's kind of on the same level, but the entry point can be slightly trickier than getting the CRUD, because all those dances that you need to take into account. Also, this may seem complicated because of the fact that event sourcing is usually used and it shines the most in more complex domains, like domains where regular CRUD applications, CRUD approach is insufficient, whereas where complex domain model kind of naturally emerges, where you need to do something more than just creating, reading, updating, and deleting records, and you don't care about the data persistence, like the history of the data and stuff. Hence, the kinds of indirectly, you may perceive the event sourced approach as a different and more difficult than regular CRUD one. And what are benefits and trade-offs of event source application, event source, let's say, architecture? Because if there are benefits, there are always some trade-offs in there. The first one, and the most commonly known, is the audit trials, because you store the events as a source of truth. You store everything that happened in your system as a set of events, as a stream of events, and this is the only source of truth for your system. You are able to get the entire history from the very beginning. So in case of, let's say you work in a highly regulated domains like, I don't know, finance, healthcare, I don't know, airlines, whatever, you may need to have that kind of requirement, that you need to be ready to be able to show reports, to be able to give kind of entire history, what really happened in your system. And you may say, okay, I can do that in a CRUD systems. Yes, you can, but the thing is that in a CRUD system, it's kind of a side project. It's a kind of nice to have thing, because it kind of goes in parallel. You just do your business logic, like saving, updating, deleting records. And by the way, you may want to save some events somewhere, some audit events somewhere. But at some point, I kind of guarantee you that at some point someone will either forget to save that event or save an event with not enough data in there. And then you will have troubles getting this audit trials, like correct audit trials, the audit trial that is meaningful. The other kind of benefit is data insight. And data insights, either for business or for product development in the future, because you have entire event log from your entities, from your systems. You can do different types of analysis from various of angles to see. Maybe you may be able to discover new features, new products, new ways where your product or your system may come in. What needs to be improved, what needs to be dropped because it's not being used extensively by users or stuff like that. This is because you have only this event log, and this is your only source of truth for that. And you can do all that business analysis based on this event log, because you have entire history from the beginning of your system. Scalability and performance. As usual, every single approach promises you scalability and performance. But this one is kind of fine because it naturally employs the CQRS principle and CQRS approach. Because like you can do CQRS without event sourcing, but doing event sourcing without CQRS doesn't really make sense, because it's like kind of one with the other kind of complements a lot, and there's so much benefit from approaching your system from that way, giving you the scalability and performance. Most of the system nowadays are read heavy. Most of the time users and kind of consumers of our system spend reading the data, not writing the data. Of course, there are systems that are write heavy than read heavy, but in general, you are more often read the data than write the data. That's why separating the reads from writes gives you the way to scale both reads and writes like kind of independently. If you need read heavy system, you may scale the read side heavily and leave the write side as it is for cost-effective reason and so on. And kind of trade-offs now, debugging and tooling. I mean by that if you wanted to debug a system, or if you wanted to debug a state written as a state in a let's say CRUD meaning, so single row in a database, you just go in a database, do select asterisk from table, and you're done. You get the system, you get the state. You can inspect the state, see what happened. I mean, you cannot see what happened. You can see what the state is at the moment, but you cannot know what happened except you have logs or metrics or monitoring, so stuff like that. In event source systems, it's a bit trickier to do that, because you have like so single stream of events, and you need to apply these events, like rebuild the state in order to see where you are. So for that, you need to have tooling. And usually the events where they are saved in a store, they are saved in some kind of binary fashion, may not be human readable. It may be JSON, but it may be, for example, protobuf, which is not easy to grasp. Like you cannot go through that like with a glimpse of an eye and see if it like what happened. You need to have a tooling in order to rebuild that state and see and inspect that stuff. But that gives you kind of time travel abilities. You can set a kind of breakpoint at even moment in time and see what was the stream, what was the event state up until this moment. So again, some trade-offs, but you're still getting something, trading the kind of easiness of having just select star from table. Embracing eventual consistency, it's something that you need to have at the back of your head when working with event source systems, because usually event source systems end up being eventual consistent. There are ways to achieve strong consistency if you really want, but they are not meant for that. And I would say that in most cases where you think that you need to have strong consistency, you actually don't. I mean, you may get away with eventual consistency if you think about the process, if you think about the problem that you have and approach it from the slightly different angle. And approaching eventual consistency gives you high boost in terms of scalability and performance, hence the CQRS and all that stuff 2 points above. But on the other hand, there's a saying that you are not Netflix, so you should not like jump into the event source and try to use it in every single component that you want that you have in your system, because it may not be for you. It's, as I said, it really shines in systems where you know that you will need to have audit trials, you know where you need to have complete history for some legal purposes or stuff like that. When there's a complex domain model that benefits from having a lot of time invested into domain analysis. So if you really have systems or services that are really simple, that you can get away with having just a CRUD approach, create, update, delete. You don't care about the history, you don't care about the versions, you don't care what happened next, you just care about the current state. It may not be an approach for you. Because as I said, it's a bit more complicated than the CRUD. It's a bit more difficult to grasp than the CRUD, but I would highly recommend to at least give it a try. I mentioned the domain discovery and the domain modeling that event source systems shine in complex domains. This is something we need to really focus on when building event source system or event source components. And it kind of goes hand in hand with domain-driven design approach. Hence the words aggregates, bounded context, and all that stuff. They are all kind of floating around all that event source concepts. You really need to focus on domain modeling because you need to discover the aggregates. You need to discover what's gonna be the thing that you are gonna emit the events for. What this command handler from the previous pictures gonna work on. Is it gonna be account? Is it gonna be just a single transaction object? Is it gonna be user? Maybe in your case. It really depends on your model. So you really need to spend time on domain modeling at first to kind of avoid complexities in the future, because you may end up having a situation that you modeled your domain wrong for some reason. You need to rebuild your stuff later on, and that's kind of causing some more complexities than necessary if you are doing the domain modeling properly and spend some more time on domain modeling at the beginning. And an example with the domain modeling, regarding domain modeling and discovering the domain, an account example. It doesn't really matter what are the methods and what are the events, but you can, the orange ones are the commands that some kind of client, user, whatever can issue. There is an aggregate user account, for example, and the yellow ones are the events that are emitted by this aggregate. You may model account that way as a single aggregate, and your event log will be growing and growing with every single deposit, withdrawal, exchange transactions. You will just save more and more events. I mean, few events for withdrawal, few events for deposits, few events for exchanges, and that event log will be huge. This perfectly valid approach. I mean, if that's your domain, that's how you discovered it. It's perfectly valid approach. You will have one account, you will have entire history of these events. So as I mentioned, audit trials, time travel, all the analysis, it's perfectly fine. But at some point, or at the beginning, or somewhere in the middle of the project, you may find that, okay, your domain is getting a bit more complex, or your event stream is getting bigger and bigger, meaning that your aggregate is getting more and more responsibilities. It does more and more stuff, it invokes more and more methods. So you may think of breaking your aggregate into several aggregates that are smaller. So you may, for example, want to have one for deposit transaction. You may need to have one for withdrawal transaction, exchange transaction, something that keeps user balances, and so on and so forth. You may have multiple aggregates that are shorter, but they kind of describe the domain that you discovered a bit better. I don't say that this one is better than the previous one. It really depends on your context. Embracing eventual consistency. This is another point that I mentioned before. In an event source systems, it's pretty much usually where you will end up with an eventual consistent system. Because of the CQRS stuff being applied, it's your events are being written to the by the command side. Events are being written to the event store, and the events are being reacted on the other side of the system, usually in a non-transactional way, in order to be able to scale, in order to be able to get more performance from your system. And you need to kind of ask yourself, while modeling the domain, while talking to the business, whether you really need strong consistency here, or maybe not. The classic example is that kind of appears usually on questions regarding event sourcing and eventual consistency stuff, is what about user email uniqueness? I want user to be sign up with an email, and I don't want two accounts with the same email. It sounds easy in a CRUD domain, like in a CRUD world. You just put a unique constraint on a database and you're done. Like if a user tries to sign up with email that already exists, you'll just reject that because you cannot save that because of the constraint. In event sourcing world, you cannot really do that because you don't have the database with the model. You don't have the constraints. You cannot set constraints in an event store. So how we can approach that? Embracing eventual consistency in here, maybe, for example, with embracing eventual consistency, there may be, for example, a solution that you may want to let the user create that account, mark it by an event, obviously, mark it as a kind of inactive yet or pending processing, whatever. And then when the event gets to the read side of your system, that read side has constituted the model, which is in a relational database, that has a constraint, and that part has that constraint. And that constraint gets violated. So you know that you cannot create yet another account with that email. So if you cannot, you can issue the command back to that entity and tell it deactivate account because duplicated email or something. And then you will kind of store an event account deactivated because of duplication. That's one of the approaches. You get that stuff done with eventual consistent, but what you get from that is that at some point in the future, business may come to you and say and ask for the report or analysis. How many attempts for creating duplicated account was there over like last few years? And what were the emails that were kind of impacted by that? With the CRUD approach, if you don't have these events that you saved, let's say a site, or you don't have logs from like 5 years or something, kind of unusual, you are not able to answer that question. And with an event sourcing, if you do it the way I just described, you just have an entire event log. You can see how many attempts were there for which emails, when they were, when they happened, and all that stuff. So this is this data insight that I mentioned before. Event sourcing architecture. I put the architecture in the quotes because to me it's not like the architecture for entire system as I mentioned before. It's to me it's a really local thing. As I mentioned before, it's the approach to state management and approach to storing the state, or the way that we kind of store events instead of the state. But it should not, to me, it should not leak outside of your system. So assume you are working in a kind of microservices or just services way, that you have multiple services that kind of talk to each other. You should not force the other systems around you to know that you are event sourced. I mean, it's your take. Whether you use, I don't know, Postgres, whether you use MySQL, whether you use MongoDB in a regular CRUD approach, the other systems don't care. And that should be the same thing in here. If you are using event sourcing, the other systems should not care. You should be able to offer the same API, or pretty much the same API, in and out of your systems. Like, this is kind of implementation detail that you decided to store the state as a series of events, not as a single row in a database. And because this is a local approach, we should not leak. Usually we don't want to leak our implementation details to the public. That's why the events that you keep, that your aggregates issue to the event store, that you aggregate save to the event store, you may want to consider them as private. Meaning that if you really want to have to communicate with an event with an entire world, like outside of your systems, you may want to consider kind of integration events, like yet another layer of abstraction, because we know that yet another layer of abstraction solves all the problems in IT, usually. You may want to think about this kind of layer where you translate your private events to events that are kind of meaningful to the public, your public API. So that when you change your aggregates, you remodel your aggregates, you add a field, you remove a field, you change your event representation, they are not impacted by that. You still keep emitting the same events, the same formats of data that you were doing before. You may do that, or you may not want to do that, depending on your use cases. If all the events that your aggregate saves are kind of domain ones and are important for the others, you may want to go ahead with that, but be aware that with that you may be leaking the format of your events and internal data from your service that you may not want the others to know about. Events evolving over time, which kind of relates to the previous one. If you change the field, remove the field from the event because some new property, some new field on a user, the form that user fills on the web page appeared, you want to have save some more data or remove some more data, or I don't know, change the event definition for some reason because the feature is no longer used or it used slightly different. You may need to, or maybe you need to think of versioning strategies from the very beginning of the system. The kind of brutality of the event source system is that if you decide to go with an event source system, you need to be prepared to support all the stuff you had in all the events you had in your systems since the beginning of the world. Because even if the feature gets discontinued, even if it starts being used for after, I don't know, half of the year, you still need to keep the events around because you need to be able to reply the stream from the very beginning up to the moment of now. So you need to be able to kind of interpret the events that happened. And for that, versioning strategies are really, really important in that. So you don't need to leave it to the moment where you really need to have something being versioned. You need to think about that upfront. So having like plain text representation of an event may not be a good idea. Having JSON is slightly better because it's kind of structured. But for me, personally, protobufs is the winner here because it gives you clear definitions, clear rules of what you can change, what you can't change, and what was going to be the consequences of adding field, removing field of that type, what you can do, what you can refactor, and all that stuff. By the way, the colleague from Software Mill has written a great post about the protobuf versioning strategies recently, so you may want to check that if you are interested in that. It not only kind of relates to event sourcing, but all that stuff related to protobufs, whether you do it gRPC or whatever kind of message passing or storage. So you really need to be aware of the way that you are going to version your events, even if you don't do it from the start. I mean, even if you don't need versioning strategies from the start. Also about the versioning, Greg Young, who was supposed to be there yesterday, he has written a book, versioning event sourcing, I believe it's a title, and the book is kind of 90% finished for like 6 years now. But it's still really valuable. I mean, even if the last 10% is missing, I would highly recommend it. Also, the requirements may change. Next to the, or maybe the events may change as a result of requirements change. Some new features added, some features were slightly modified, some features were dropped, hence the other ones need to adapt in order to, for the system to stay being usable. Or you might have been slightly wrong on a domain modeling session before discovering the domain. So what you could do with that, how to refactor event source system, how to refactor the aggregates. If I had a row in a database, in a CRUD approach, I would have several columns. I would just modify my code, just issue one flyway migration, and be done with it. It's not that easy in event source systems. While you can quite easily change the code itself, like command handlers and stuff, because it's basically your business logic, so you know exactly what the business logic needs to do. So you know how to refactor it, how to split the aggregates in there. But you may want to, but in addition to changing your code, you will need to change your event stream or rebuild your event stream or rewrite some events. I mean, not rewrite in terms of like modifying in place, but take the event stream, kind of reply it in a form of commands somehow, and apply that commands to your new system, new structure of aggregates, so that all the deposits in this case, for example, all the deposits, all the withdrawals, all the exchanges are kind of saved in their own event streams. It may be slightly more difficult than just issuing flyway migrations for CRUD systems. It may take some more time to come up with a plan for that, depending on the complexity of your aggregates. But the thing is that because you have this immutable store of events, you can, for example, run the migrations kind of in parallel. Your system can continue to work on production, and you can run the migration aside. And only after the migration catches up and you verify it's all good, all the aggregates have been created properly, it's all fine, you make the switch. Again, trade-offs and decisions you need to take. Frameworks, so the tools that we really like, the things that we really like. Someone said that, I don't know, maybe it was Greg on one of his presentations, but I don't remember, that framework is just someone else's applications, so someone else's application that was just kind of adapted to generic stuff, like stripped from the domain specific things from that person and put on GitHub for you to use. So meaning that it has some limitations, and at some moment when you start using a framework or any kind of tool, you will hit some limitations if you do kind of unusual stuff. And for example, this is a Scala code. Sorry, no Java in here. This is an example from akka persistence. This kind of contrived example, but still, we are handling in this highlighted part. We are handling the command. There's a command handler for withdraw command. And you see, if you see the first line, the underlined line of code in here, we are checking a business constraint here, kind of invariant in an aggregate in a domain-driven design language, let's say. We are checking in from the business point of view, you are allowed to withdraw. The command can go through. But after that, in this if statement handling, you have this effect.persist, effect.then reply, and stuff like that. This is all akka-related thing. This is all framework-related stuff. And now you are ending up with having your domain logic kind of slightly tightly coupled with your framework. I mean, it may not be a big deal in this case, in this example. It's easy. You may live with that. But I've seen projects where the actors, so the entities, the aggregates in the akka world, had like thousands of lines of command handlers and all that stuff, and all the logic was so tightly coupled with all the machinery from the framework that it was really hard to do any change in the systems. For example, testing. You may want to have domain logic, and the domain logic tested really well, tested all the invariants, all the use cases, all the business cases, edge cases that you may want to have in your business code. And on the left, if you look at the underlined code parts, all that stuff is related to framework. You need to extend some kind of test base in order to have the actor system running. You need to spawn the test kit something. You need to create a probe, which is going to be kind of something that records the messages that are being sent or stuff like that. It doesn't really matter what it does. What matters here is that your test, that you can, whether you can deposit or whether you can withdraw money from account, your test kind of tests two things, does two things. It tests your infrastructure and it tests your business domain. On the right, this is the same test, basically the same test, but written only in a domain language. When you have domain language domain code totally separated from the framework. When you have domain on one side, your model on one side, the framework in here, and you have really tiny layer that is just responsible for gluing that stuff together. So you can pick the domain model, test it independently, write tons of tests that are fast, that are reliable, that don't need any actor system, any framework, any database, or all that stuff, which is really valuable in the long run. In the system that I work now, we have tons of tests for business logic that are easy to write, easy to read, easy to change, and they are fast. That's because we are approaching it on the right way, not the left way, where they kind of constitute the actor system and all that stuff. Sure, we have we have some tests for checking if our domain logic plays well with the actor system, whether the events get saved properly or not. But still, it's not the responsibility of your business logic to know about the framework. Replying events. Beware of the long event streams. If you were on a presentation by Milan before, he talked about the long event streams, like millions of events and stuff. As I mentioned before as well, in order to handle a command, you need to reply all the events, like reload all the events from the event store for a given entity, reply them to the empty state, like one by one, have a state, and only then apply the command to that state. If you have an entity that has, or aggregate that has millions of events, like 100 of events, okay, it's fine. Any database is happy to take that load and give you the events, and you are in your code, you are just applying that in a milliseconds, it's fine. But if you are starting to have aggregates that have long stream of events, so for example, the account from the previous example, the first example of the account from the previous example, the event stream is growing. Assuming the user was really active on his account for like 5 years, how many different events it may have? Millions, maybe. And if you try to, on every single request, if you try to load millions of events, your command handler is gonna be super slow. You are gonna pay tons of money for IOPS if you are in a hosted solution somewhere in the cloud. You will pay for the network throughput, because you need to send all these millions of events back and forth. You may want to consider that. And that's why the domain modeling part that I mentioned before is really important in here. Some say that storage is cheap. All the events will generate, obviously they will generate more storage than the CRUD system, because in CRUD you have updating or working still all the time working on one row. On the events, the storage is growing. The storage is cheap, but still, is the network throughput cheap as well? Is the IOPS in your cloud provider cheap as well? Is the time that you need in order to reconstruct the state, is it really cheap? Can you afford for having entity that's gonna handle the command for, I don't know, half of the minute, from which like 99% of the time is gonna be replying of the events? Probably not. One solution to that problem is keeping aggregates around. So if you load one entity, if you happen to load one entity, which is kind of costly in terms of loading, it has, let's say, millions of events, because this is how things look, and you cannot change it. You may want to keep the aggregates around in order to reduce that penalty. This works in a way that if you load them once, for example, at the beginning, at the start of your systems, you boot up all that stuff and load all the aggregates into the memory, the ones that you need, and you keep them around until the system gets restarted or the entity is kind of terminated business-wise. So you don't pay the penalty on each and every request. And this is basically where kind of akka and actor model shines. But thing is that you can do that only if you can guarantee so-called single writer principle. If you have multiple nodes, multiple processes, multiple sources of the commands in there, you need to be sure that in your system you only have some kind of infamous singleton, not in a singleton pattern meaning, single instance of the aggregate that you will know that only that aggregate will be handling the commands and events for that entity. For example, if you are using Akka, you may want to go with Akka cluster and Akka sharding, which will give you that guarantees, these exact guarantees. But again, going with that kind of increases the complexity on your operations side, because you need to manage cluster, you need to manage all that clustering things, you need to be aware of split brains and all that stuff around the infrastructure, around the clustered infrastructure. The similar thing may be achieved if your commands are only Kafka based, let's say Kafka in terms of messaging, where you can guarantee single assignment of a partition, that only one consumer will get a given partition. If you can partition your commands in a way that you can assign the commands for user A going always to partition number 1, you may have one consumer being responsible for getting commands for that user only, effectively achieving the single writer principle. But again, keeping aggregates around, that's one of the options that you may go with. May not be the best one, depending on if you want to pay the price of the complexity of your infrastructure. Snapshots, things that Milan mentioned as well. Another take to reduce the reply size, to reduce the cost of loading the entity into the memory. They work in a way that you have this long event stream. From time to time, you do the snapshot of that stream, of that state, how the state looked like, reconstituted after that number of events. And from now on, instead of going to the very beginning of the stream, you just start loading a snapshot and applying only the events that happened after that snapshot, which looks really fine, and it's really promising. Probably most of the event stores give you that tool. But again, this is, if you go with a snapshot, it kind of increases in complexity, because you need to manage the snapshot, manage creation of the snapshot. You need to be sure that whenever you do any change in your events or your stand representation, all the snapshots are still compatible, that you can still recover, like reply the entity from the snapshot after your code changes. So this is yet another complexity in your system. You may want to go with that in order to reduce loading time for the entity, but it may not be a solution that is really easy in terms of maintenance, future maintenance, and complexity. That's why you may want to consider taking a step back if you see that you have really long event streams, like millions of events, thousands of events maybe. You may want to consider taking a step back and seeing if you maybe set the boundaries wrong for the entities. As it was the same on the account example. Maybe the first option was not really good in terms of like long-living aggregates, because the event stream is getting hairy, it's getting more and more unmanageable. You may want to take a step back and try to see whether there's maybe a domain concept that emerges that you missed on a domain modeling part. Split that into some entities that have shorter lifespans. Maybe you may want to have still the same entity, but have an event that will kind of, in a financial terms, for example, close the year and start the new aggregate for new year, for new day, for new month, something like that. Maybe there's a concept that you missed. So the longer growing event streams are usually the sign of events being like domain that might have not been discovered correctly. Side effects. That's a thing that kind of bothered me for a while at the beginning. How come it happens that you do something, you save an event in persisted stuff, and you do something, you notify user, you send an email, you do something in the external systems, but there's nothing in the command handler that does that. And usually it's nothing in the command handler that does that because it's kind of unreliable. You cannot rely on the command handler to do that, because the only responsibility of command handlers is to check the domain logic, take the decision, and persist the events. The command handler should not do any side effects because of the delivery guarantees, inconsistencies that may happen. Let's consider what would happen if you first save the events and then try to send a message to Kafka, for example, and you crash in the meantime, or the other way around. It's totally unreliable. You cannot rely on that. That's why there are the other places where you handle events. Internal event handlers and external event handlers, I call them. The first one is on the read side, where you get the events from the event store, you act on that event and you send the message to Kafka, having the information from the event. You call the other service, you do whatever you want. You update the table in the database in order for users to view the data in some nice UI. But it has some, it's kind of the default way, but it has some issues. The latency, before saving an event and the read model reaching getting that event, some event stores do that by doing polling to the database. So the polling is kind of discrete, so you don't know, you kind of trading off the latency. It may take some time before the event reaches the read side, the read side event handler. You may or may not care about that. Poisonous event. If one event stacks in a queue in an event handler, all the events from the queue will be stuck, and all the processing for all the other entities may stack as a result. Having not enough data in an event. This is the thing that you emitted an event, you have an event handler, but you cannot really complete the build the request because you need just one more field that you happen to forget to save in a command handling part. So you may still want to consider what should go into that event. Internal event handlers, if you can collocate the event handlers for sending messages and stuff into, like next to the command handler, so that right after saving the events into the event store, you can in the same process act on the events, having the state together that was used in a command handler together with an event. That solves the issue of lack of data in an event. That solves the issue of, kind of solves the issue of latency. But for that you need to have at the back of your head things like what will happen if I crash at the moment. You need to be able to recover the entities. You need to be able to remember the entities that were in memory at the moment of crash, to be able to restart them and restart processing after starting them. So again, trade-offs. Read models and projections, I called it event sourcing to the max. I mentioned before about the strong consistency stuff that you may really want to have at some points strong consistency. Sure, you can achieve that, but it's not the really point of an event sourcing. You can achieve that in a way that you may, in the same transaction, database transaction, Postgres, MySQL, whatever, save event to an event store and update your read model. But it doesn't really scale, because if you happen to save, to update events and several read models in the same transaction, it may start getting slow. You are risking that one of the read models gets somehow inconsistent, and you don't want to fail your event persistence because of some of the read models being inconsistent. So that may not be a thing for you. If this is a one model, it may be acceptable. But if you are starting to do for 2, 3, 4 models, it's not the right way, at least to me. Too many read models. With the polling, if you start to poll the database for the events from too many read models, you may end up kind of pushing the database to the limits, effectively increasing your latency because all the events will be handled with some delay because of the load on the database. So you may want to consider that. So again, the solution usually, yet another layer of abstraction, putting a message queue between your events journal and your read side. In that way, if you can do that, the only need for that, the only requirement is that you between the events journal and message queue, you need to ensure the events ordering, because the order of events matters everywhere in this system. You need to ensure the events ordering for single entity. If you are able to do that, put that to Kafka or whatever message queue you want, you can scale the read side indefinitely. Like tons of the consumers, tons of the read sides, tons of the models, database view, systems calls, Kafka processes, whatever you may come up with. And that's basically kind of beauty, to me, the beauty of the strongest part of event source system, that you split, like this, it's actually the CQRS thing, that you split your reads, your writes from your reads, and you can scale your reads, and you can do stuff on your reads as if you were on a strongly consistent system, with all the guarantees, with all the benefits from having the read side separated, read side really performant, and events being the only source of truth for your entire service. So wrapping up, I would really advise you to give it a try if you haven't tried it yet. As I said, it's a local stuff. To me, this is a local thing. You can give it a try on a single aggregate, single domain concept. If it flies really well for you, try to apply that to one more domains. If it makes sense, if you are in a system where that really matters, that you will benefit from audit trials, that you'll benefit from having time travels, you can afford eventual consistency and stuff like that. It's a really valuable tool, and for me, it's really good to have it in my toolbox. Thank you. Now, questions. I don't see questions. Need to do it like that, probably. Don't you think that event sourcing everywhere leads to terrible workarounds? I can say without reading all that, the questions, the rest of the questions, yes. Why put it everywhere? I wouldn't put it everywhere. That's why I said that it's not, like, it's local thing. You may have one aggregate that will benefit from time travels, that will benefit from events, audit trials, eventual consistency, and scaling reads and writes and all that stuff. But the others may be perfectly fine in a crude approach. You just communicate with them and be done with that. Like, all or nothing solution are usually bad choices. Should we create one big snapshot of everything or many little snapshots for each object? Depending what do you mean by object. Snapshots are usually per event stream, and event stream is related to the aggregate itself. So you usually create a snapshot per aggregate. There are different strategies for creating snapshots. You can create snapshot every 1,000 events, as Milan said, like every Friday. For example, in my case, in my project right now, we are creating events we are creating snapshot after some event happens, after some type of event happens. Like, we know that, okay, we finished the transaction, that thing happened. We have the state that is not that complex to store in a database, that is kind of clear. We are okay with saving that as a snapshot, and only then we are saving that snapshot in a database. So the snapshot should be saved according to your business rules. If you don't have clear business rules, maybe just a number of events is fine. But you need to be aware that you need to manage the snapshot. If you have the snapshot, you are kind of trading off this events as a single source of truth, because the kind of subsequent source of truth is your snapshot in here. And I guess that's answered the question. So many little snapshots, I don't think, depending on how often you want to create the snapshots. I wouldn't create a snapshot on every 10 events, unless the events are really big and the loading of them is, load time of them is really high. Thank you.